So we're going to continue on with the lesson 3 on factoring polynomials. We're going to focus on factor theorem. And what does factor theorem says? It says here, let's read it first and see if we could understand it and see if this makes sense to us. Okay? So it says here, factor theorem. X minus a, okay, x minus a, this is a binomial. X minus a, the binomial, is a factor of the polynomial. Okay, p of x is a polynomial, right? It's just shortened. If p of a is equals to 0. So that's what they're really saying in here, is that apply the remainder theorem. We're going to apply the remainder theorem, and if it says if the remainder is 0, then the x minus a is a factor. Okay? So also, if x minus a is a factor of a polynomial, then a is a factor of a constant term of the polynomial. Okay, a is the factor of the constant term. Okay, we'll talk about the constant term for a second. Okay, we'll talk about that. So okay, so looking at this polynomial first, okay? Looking at this is our polynomial. Which one do you think is the constant term? Constant term. The constant term, that means the plus 12. So this is the constant term, right? So constant term. So here we go. We'll see here. That's this one here. If x minus a is a factor of polynomial, then a, whatever that number is a factor of the constant term. So see here. Use the factor theorem to determine which of the following binomials are factors of polynomial. So x plus 1. We're going to see if this is a factor. What is the a value for this? Minus 1. Because it's going to be x minus negative 1. So your a is equals to minus 1. Okay? So what we're going to do is we're going to figure out what is the remainder when, yeah, for p minus 1. So we're going to go here. So negative 1 cubed minus 6 times negative 1 squared plus 5 times negative 1 plus 12. Okay, so let's see what that number is going to give us. Okay. It's going to be p of negative 1 is equals to negative 1 cubed is minus 1. Orders of operation here, exponents first. So negative 1 squared is positive 1 times negative 6 is negative 6. 5 times negative 1 minus 5 plus 12. And then we add them up. Okay, so p of negative 1 is 0. Okay, what does that mean? What? Yeah. So it says here, this is what the factor theorem is. If we figured out if the remainder is 0, then the x minus a is a factor. So therefore, okay, x minus negative 1 or x plus 1. X plus 1 is a factor, right? Since the remainder is 0, that means it divides evenly, right? When we have a remainder 0, that means it divides evenly. No remainder. It's a factor. Okay. Just want to try. Next one.
Just a second.
Yes, of course. We're going to try this one. Okay. So our question is x minus 3 a factor? Okay, well, let's use our factor theorem. X minus 3, what's the a value?
It's 3.
A is equals to positive 3. So we're going to go, what's the value of the polynomial when x is 3? Okay, so it's going to be substituting 3 wherever we find x. So 3 cubed minus 6 times 3 squared plus 5 times 3 plus 12. Okay, orders of operation. Did you say yes already? I'm not even there yet. So 3 cubed is 27 minus 3 squared is 9 times negative 6 is negative 54 plus 15 plus 12. So P3 is equal to 27, 54. Yes, it's 0. Okay, so that means the remainder is 0. Okay, since the remainder is 0, therefore x minus 3 is a factor of the polynomial. Is that okay? Yeah, what we're trying to do is that what is the remainder? If it's 0, it is a factor. If it's not a 0, it's not a factor. Okay, let's take a look at second last. Okay, what's the a value here? 4. Excellent. So a equals to 4. So we're going to evaluate p of 4. So let's go ahead and do that. Oh gosh, I'm going to use my calculator here. 96? And negative 96 plus 20 plus 12. Oh, so P of 4 is also 0. P of 4 is also 0. So what does that mean? Since
It's a factor
the remainder is 0, right? There's no remainder. That means it divides evenly. That means it's a factor. So since the remainder is 0, therefore...
So the positive's always a factor, or the negative's a factor, the other one's not going to be, right?
Oof!
Because it can't, it's going to be different numbers.
I don't know yet.
Trick question, you're just making us see work.
I'm just going to say we don't know. Okay? So therefore, x minus 4 is a factor of the polynomial. Yes? Okay.
We have to write this or
No, I want...
we can do it in maths.
Yeah, right now I'm writing everything down so that when you refer back to it, you know, it's like, oh, why are we doing this again? Like you, because you want to know what the remainder is, and if the remainder is 0, it is a factor.
No, I'm not talking about.
Oh, okay.
Talking about what is like.
Oh,
Like way
you
of-
mean like,
way of the maths.
you mean this part? This part?
This was saying
Oh, since, da-da-da? The statement at the end? No, sorry. I'm gonna stop talking. I'll let you talk. Yeah.
no.
I'm listening.
We have to write all these because they are way like in maths and they are like this one. And just put short. Like.
Oh, you can just go P40? What were you thinking of writing?
No, like in maths I can write like saying you can put dash. You get me?
You know, like that.
Well,
Like therefore?
yeah.
Oh, okay. Yeah, that is therefore. Yeah, that's a shorthand of therefore. Yeah. Okay, so next one. Is x plus 4 a factor? Is x plus 4 a factor? Yeah. Yeah. What is the a value? A equals to negative 4. So let's evaluate p of negative 4. So negative 4 cubed minus 6 times negative 4 squared plus 5 times negative 4 plus 12. Okay, so negative 64 plus 96 minus 20 plus 12. Okay, the answer is 24. Oh, minus 96. Minus 96, yeah. Ah. Minus 168. Negative 168. Okay. Negative 168. Okay. Since the remainder is not 0. Okay. Okay. Since the remainder is not 0. Okay, therefore, x plus 4 is not a factor of the polynomial. Okay, polynomial p of x. Okay, now we're doing all these stuff.
Just a question. So, like when the remainder is not 0, it is not a factor of polynomial.
Yeah. No. That becomes, it does not divide evenly, right? It's not a factor. Yeah. So I mean, we could try to divide. We could try to divide. If we divide it, the remainder would be negative 168. When there's something remaining, that means it doesn't divide it evenly, right? So let's take a look at each desk here. Let's take a look at each desk. So if I say, okay, go in groups of 4, and there's how many of us in here? Oh, I'm counting students. Hey, group yourselves into groups of 4. Does it divide evenly?
No.
No. There's going to be one person remainder. So it doesn't divide evenly. So same thing over here, right? If it doesn't divide evenly, then it's not a factor, right? So we're going to tie it all together. We're going to tie it all together in taking a look at example number 3. Okay? Why are we doing all these things? Okay? We're doing all these things so that at the end, this is our main goal. Our main goal is to be able to graph the polynomial. Okay? That's what we're going to try to do. We're doing all these baby steps so that later on, okay, at the end, can we graph this? Right? Previously in your old course, back in the days, you were graphing linear functions. Yes? You know how to graph a line. In your previous course, you know how to graph a quadratic function, right? X squared. Yes? Now, in grade 12, we could graph cubic function. You know, when it says x cubed, we're going to also graph x to the 4th, x to the 5th, x to the 6th. So these are our baby steps, and we're doing all these things to prep ourselves to be able to graph these things without graphing technology, without graphing calculator, and any graphing software, by hand. And we're not going to do table of values either. Yeah, that's going to be really. So here we go. Okay, so that's our main goal. We're doing all these baby steps, but to do that, we have to first factor fully. Okay, it says here, example 3. Example 3. Determine one binomial factor of the polynomial x cubed minus x squared minus 8x plus 12. Okay, minus. So what we're going to do is we're going to test some a values. Okay, because remember, there are a values in here. At the beginning, it says here, we're going to look at the a value, and the a value is a factor of a constant term. So here, what is the constant term in this polynomial? 12. Okay. So what are the so this is a constant term. So what we're going to do, the a value will be factor of the constant term. So what are the factors of 12? Okay.
3,
Oh,
4,
oh.
6.
Okay. Yes, all of you are right. Okay. It could be plus or minus 1, yes? Right? Okay. What else? Plus or minus 2. Perfect. One of those numbers will give us a remainder of 0. Okay? One of these factors of 12 will give us a remainder of 0 for this polynomial. So what we're going to do is we're going to test it out, okay? So we're gonna test it out. What's P of 1?
Minus one.
What is P of 1?
It's minus
Okay, it's gonna be 1 cubed minus 1 squared minus 8 times 1 plus 12. So P of 1 is equals to, this is gone, this is minus 8 plus 12, it's gonna be 4. Okay, the remainder is 4. Okay, that's not good. We don't want that one. Okay, let's try P of negative 1. What would be P of negative 1? So it's going to be negative 1 cubed minus negative 1 squared minus 8 times negative 1 plus 12. Okay, that's going to give us negative 1, and then this is 1, and then minus 1. This is going to be plus 8, plus 12, and it doesn't look like it's going to be, right? So it's P of negative 1 is not 0, right? This is going to be 20, 18. Okay. Okay, so, okay. Let's try a negative 3. Did you try it already? Okay, well maybe. Okay. Let's try a negative 3. Try a negative 3. Okay. So why don't you try a negative 3? I'll try negative 3 as well. What about negative 3? Does it give you 0? Right? This one is going to give us negative 36. These two are going to give us positive 36. So P of negative 3 is 0. Okay, P of negative 3 is 0. Okay, so we got one factor. We got one factor. So what's the factor? Since A equals to negative 3, okay, gives us a remainder of 0.
If you're going to the ocean, there's nothing.
Okay, then what's the factor? It's going to be x minus a. So a is minus 3. So x minus negative 3. That means x plus 3 is a factor. Okay, x plus 3 is a factor. Okay, that's one of them. Can you find another one? Okay. Anybody would like to try 2 or negative 2?
Like we should do it or it's choice?
Hmm?
We should do it or it is choice?
You try it, yeah, because we found one, but there could be another one. Okay, what number did you try? -2? Okay, so you tried P of -2? P of -2? Oh, +2. P of 2. Okay, so that would be 2 cubed minus 2 squared minus 8 times 2 plus 12. So P of 2 is equal to 8 minus 4 minus 16 plus 12. So P2, that's going to give you -20, +20, 0. So what does that mean? It means if P of 2 is 0, then
A.
x minus a is a factor. And what's the a value? A is the 2. So x minus 2 is a factor. Okay. So we found 2 factors. Okay. I'm going to stop right there for a second. I'm going to show you, okay? I'm actually going to show you what the graph of this polynomial looks like. Okay? And let's see if you can pin. Okay, okay, that's not what I want. This is what the graph, I'm showing you the graph of that. Can you see where the a value is in that graph? Where is that a value in that graph?
That one, the left side.
Okay, you can come up and show everybody. Okay, remember, where's the a value in the graph? Okay, remember, our a values are -3 and +2.
-3?
Our a value is -3 and +2.
Okay. This one, -3, and this one, +2.
Yeah. Yeah. Now you see, we're now kind of seeing. I kind of just showed it to you right now, but this is where we're gonna head. Okay, we're trying to figure out. Eventually, what did you call it earlier, Hassan?
X-intercept.
X-intercept.
When the graph cuts x is the area.
Yeah.
But the other point is doesn't cut x-intercept.
Hmm.
The other point is doesn't pass the x-intercept.
It touches, right? At 2. Okay? Okay? It does touch it. But it doesn't go down. Now, why? Oh, okay. Now we're starting to reveal a whole bunch of stuff from here. And you want to say that again? Maybe louder.
The constant term is the y-intercept.
Correct. The constant term, the 12, is the y-intercept. This is the y-axis, and the y-intercept is right there. Okay. Now, good. And later on, we're going to reveal more as we talk about this more and more. But this is the reason why we're trying to figure out the factored form. Okay? So, now, let's try one more. Let's see, okay? Let's try one more. Example 4. Okay, after example 4, we'll take a short break, and then we'll do other stuff. Okay? Hopefully fun stuff, not just sitting down. Okay, it says they're factor fully. Now, it says here factor fully. What does that mean? Okay, well, we don't know what are the factors in this. We're gonna look for zeros. Okay, now look at the A values would be a factor of the constant term. So what are the factors of 2?
1.
Plus or minus 1.
Of constant term 2 is either plus, minus 1, yes, or plus or minus 2. So we only have 4 possibilities in here, so that's kind of nice. So let's try 1. Okay, let's say A is 1. P of 1. What's that? Does a P of 1 give us a remainder 0? Okay, so the remainder here is minus 4. Okay, we don't want that. We don't.
Minus 2.
Okay, we'll try minus 1 first. Try minus 1. Minus 1. So 3 times negative 1 cubed minus 4 times negative 1 squared minus 5 times minus 1 plus 2. Negative 1 cubed is minus 1 times 3 minus 3. Negative 1 squared is going to give us plus 1 minus 4. So minus 4. Negative is plus 5 plus 2. Oh yeah, so that one is going to give us P of negative 1 is 0. Okay, so our A value is negative 1. So therefore, the factor is x minus negative 1 is x plus 1, right? Okay, so that means, okay, here we go. We're going to put everything together. We know that the factor is x plus 1. Because this is x plus 1 is a factor, that means it will divide evenly into this polynomial. Okay, so let's divide it evenly. We're going to use a synthetic division, makes it easy for us. So 3, negative 4, negative 5, and 2. Okay. Yeah, you could do long division, but it's gonna take longer. A value is negative 1.
3 would come down.
Bring down the 3. What's next? 3 times negative 1 is minus 3. And then what are we gonna do? Okay, we gotta add minus 7. Negative 7 times negative 1. Positive 7. Okay, add them together. Positive 2. 2 times negative 1 is negative 2. And that's remainder 0. We know that the remainder is 0, right? We know remainder is 0. So what's the other factors?
So is the dividing just verifying?
No, we're trying to figure out the other factors. So this is going to be 3x squared minus 7x plus 2. Okay, so the polynomial has one factor, x plus 1, and we're just trying to figure out the other factors. Now this one, is this factorable? Is this factorable?
So why would you divide to find the other factors, not just do what we just did?
Okay, why are we dividing? Good question.
Like, can't you just, do the times again?
Okay, I'm gonna do it on a separate sheet of paper. this is a polynomial, 3x cubed minus 4x squared minus 5x plus 2. So we know that one of the factor is x plus 1, right? So x plus 1 times something will give you that. So if we take this and divide it by that, the remaining is 3x squared minus 7x plus 2. Now you look at this one, because we have to factor fully. This is factored already. Now can we factor this one? Yeah? Okay. So how do we factor a trinomial? Times it together, right? That's going to give us 6x squared. 6, that will add up to negative 7. Okay. That's going to be x plus 1 there. This is going to be 3x and x. Yes? Okay. We're going to have a plus 2. So minus 2 and minus 1. Right. Yeah. So I'll do that here at the bottom. So 3x squared minus 7x plus 2. We multiply these two, that's 6, right? So 3x squared plus 2. What will add up to negative 7? Negative 6x minus x. And then factor by grouping. This is going to be 3x, x minus 2. GCF between these two is negative 1. It's x minus 2. So the factored form would be x minus 2, 3x minus 1.
Can you go back to the synthetic division there?
Yeah, I'll do that in a second. And then 3x minus 1, and then x minus 2. So this is the completely factored form. So this one, when we factor this part, it's going to be 3x minus 1, x minus 2. So what's a completely factored form? So the complete factor of that polynomial would be of p of x would be the x plus 1, 3x minus 1, and then x minus 2. That's a complete factor. Okay, so I'll give you a moment to copy that down. So you can see we're putting everything together, starting from lesson 1 to lesson 2 to lesson 3, all in one.